बिस्मिल्लाहिर्रहमानिर्रहीम रब्बिश्रहली सदरी वयस्सिरली अमरी वाहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली. Assalamu alaikum. Today we will do section 1.5 estimates and order of magnitude calculations from the book Physics for Scientists and Engineers with Modern Physics by Serway and Jewett, 10th edition. Suppose someone asks you the number of bits of data on a typical Blu-ray disc. In response, it is not generally expected that you would provide the exact number, but rather an estimate which may be expressed in scientific notation. The estimate may be made even more approximate by expressing it as an order of magnitude which is power of 10 determined as follows. Express the number in scientific notation with the multiplier of power of 10 between 1 and 10 and a unit. If the multiplier is less than 3.162, the square root of 10, the order of magnitude of the number is the power of 10 in the scientific notation. If the multiplier is greater than 3.162, the order of magnitude is 1 larger than the power of 10 in the scientific notation. We use the symbol approximate for is on the order of. Use the procedure above to verify the order of magnitude of the following lengths. As an example, we'll consider three values. For example, 0.0086 meters. It is less than 0.004 meters. Therefore, we will round it to 0.01 meter. If we move the decimal 2 places to the right, we'll get 1 into 10 raised to power minus 2 meter. Another value is 0.0021 meters. Since it is less than 0.004 meters, we will approximate it to 0.002 meter. We will move the decimal 3 places to the right and we'll get 2 into 10 raised to power minus 3 meters. Another example is of 790 meters. This is approximately equal to 1000 meters. We will move the decimal to 3 places in the left and we will get 10 raised to power 3 meters. Usually when an order of magnitude estimate is made, the results are reliable to within about a factor of 10. Inaccuracies caused by guessing too low for a number are often cancelled by other guesses that are too high. You will find that with practice, your guesstimates become better and better. Estimation problems can be fun to work because you freely drop digits, venture reasonable approximation for unknown number and make simplifying assumptions and turn the question around into something you can answer in your head or with minimal mathematical manipulation on paper. Because of the simplicity of these calculations, they are often performed on small scrap of paper and are often called back of the envelope calculations. Example 1.5 Breaths in a lifetime. Estimate the number of breaths taken during an average human lifetime. We start by guessing that a typical human lifetime is about 70 years. Think about the average number of breaths that a person takes in 1 minute. These numbers vary depending on whether the person is exercising, sleeping, angry, serene, and so forth. To the nearest order of magnitude, we shall choose 10 breaths per minute as our estimate. This estimate is certainly closer to the true average value than an estimate of 1 breath per minute or 100 breaths per minute. 1 year has 365 days, 1 day has 24 hours, and 1 hour has 60 minutes. We will make two approximations that we will assume that 1 year is equal to 400 days. The other approximation that we'll make is that 1 day is equal to 25 hours. This will simplify our calculation and we'll find that 1 year has 6 into 10 raised to power 5 minutes. In the last lecture, we learned the advantage of carrying the units along. We want to convert year into minute. 1 year is in the numerator, so we'll place 1 year in the denominator, and that is equal to 400 days, which is placed in the numerator. Then we want to cancel the days and get the answer in terms of hours, so we'll place 1 day in the denominator and hour in the numerators. We'll get 400 into 25 hours. To convert it into minutes, we know that 1 hour has 60 minutes. We'll place hour in the denominator and multiply it by 60 minutes, giving us the answer of 400 into 25 into 60 minutes, that is equal to 6 into 10 raised to power 5 minutes. The next step is easy. Find the approximate number of minutes in a 70-year lifetime. We want to find the number of minutes in 70-year lifetime. Therefore, we will multiply 70 years times 6 into 10 raised to power 5 minutes over year. We know that in 1 year, there are 6 into 10 raised to power 5 minutes approximately. If we do this calculation, we get the number of minutes in a lifetime is equal to 4 into 10 raised to power 7 minutes. To find the number of breath, it is even more simpler. Find the approximate number of breath in a lifetime. Number of breath is equal to 10 breath per minute times 4 into 10 raised to power 7 minute. 4 into 10 raised to power 7 minutes were the number of minutes in 70 years of lifetime, and in each minute the person takes 10 breath per minute, therefore giving us the answer of 4 into 10 raised to power 8 breaths. Therefore, a person takes on the order of 10 raised to power 9 breaths in a lifetime. Notice how much simpler it is in the first calculation above to multiply 400 into 25 than it is to work with the more accurate 365 into 24. What if? What if the average lifetime was estimated as 80 years instead of 70? Would that change our final estimate? 1 year has 6 into 10 raised to power 5 minutes. If we assume the average age to be 80 years, then we will multiply 80 years times 6 into 10 raised to power 5 minutes over year to get 5 into 10 raised to power 7 minutes. 5 into 10 raised to power 7 minutes are the average number of minutes in a person that is 80 years old. If we multiply it by the number of breath per minute, that is, in 1 minute the person breathes 10 times approximately, we would get a 5 into 10 raised to power 7 minutes times 10 breath per minute, giving us total of 5 into 10 raised to power 8 breath. This is still lower than our estimate of 10 raised to power 9 breaths, and our order of magnitude calculation is correct. We could claim that 80 years times 6 into 10 raised to power 5 minutes per year is equal to 5 into 10 raised to power 7 minutes. So our final estimate should be 5 into 10 raised to power 8 breath. This answer is still on the order of 10 raised to power 9 breath. So an order of magnitude estimate would be unchanged. May Allah bless us all. Thank you for watching. Allah Hafiz.